A distribution of values is normal with a mean of 153.6 and a standard deviation of 44. Find p sub 29, which is the score separating the bottom 29% from the top 71%. Well, the first thing that I notice here is that we're working with a distribution of values that is normal. And so that right there helps us decide how we're going to ultimately solve the problem. We're going to use something with respect to the normal distribution. It would definitely be a great idea to start this off drawing a bell-shaped curve to just organize the information, the pertinent things that we always need to know about normal distributions are the mean and the standard deviation. So the mean is the value that's right in the center, so 153.6, and that means my axis here is in terms of whatever units these values are in. And it's not given, but it's the number of whatever the unit value is. Now, the question is asking here to find p sub 29, and that's just another way of saying the 29th percentile. All right. And the 29th percentile, this next part just goes on to explain what that means. It's the score separating the bottom 29% of the data from the top 71%. All right, so the bottom 29% of the data might be this amount right here. So that would be 29%. And if that's 29%, then the area over here on the right-hand side, which I'm not going to shade so it doesn't get confusing, would be 71% because 1 minus 0.29 is 0.71. So ultimately, all we need to know is that we're looking for the 29th percentile because that's always area on the left end of the distribution, no matter what the input value is. So I'm looking for this value right here. I want to know what value separates that lower 29% from the upper 71%. In order to find it, because I'm looking for a value and not a probability, I'm going to use the inverse norm function. So inverse norm takes 3 inputs. The first input is the area to the left of the value that you're interested in. The next one is the mean, and then finally the standard deviation. So the area to the left of that value that I'm interested in, x, is 0.29 or 29%. The mean is 153.6, and the standard deviation is 44. So, using the calculator, I can come up with that value of x. If I go under the second in vars, which is the distributions menu, come down to inverse norm, and feed it the values 0.29, comma 153.6, comma 44. And I get 129.25. Now, in terms of rounding, it's often requested to just round to whatever the accuracy of the mean and standard deviation is. Since the mean and standard deviation aren't to the same accuracy here, or perhaps 44 was 44.0, just go to the first decimal. But usually there's going to be rounding rules to follow. Just follow whatever rounding rules are given in the problem. So 129.3 is probably an acceptable answer here. Now, some of you, when you went to inverse norm, you may have seen a menu come up. And that occurs in some of the later model TI-84 calculators. And all that's doing is just simply trying to help you see what the input values are to a function rather than having you remember what they are. So the 3 inputs to inverse norm are area to the left. So you can just type in your area to the left, and I don't know why I put 0.12, 0.29. The mean is 153.6, and the standard deviation is 44 in this case. And what you do at this point when you hit paste is you'll see the calculator takes those numbers, puts them separated by commas, and attaches them to the inverse norm function so that you get the same answer. It's just a little more convenient so you don't have to remember the order of the input values.